One of the most exciting moments of the Cassini-Huygens mission around Saturn was when its European probe successfully landed on the giant moon Titan. Flybys have since confirmed the presence on its surface of lakes of hydrocarbons whose changes, which may be attributed to seasonal effects, are being detected after years of observation. Yet Titan is but one of Saturn's 60 or so natural satellites. After Titan, the Cassini orbiter has also most extensively studied Enceladus, seen here passing in front of its big brother, a brilliant icy moon only 500 kilometers in diameter. In 2005, Cassini's magnetometer team made a significant discovery, confirmed by the orbiter's optical cameras, that spectacular geysers at its south pole are spewing wispy fingers of bright ice particles and vapour tens of thousands of kilometers outwards, and which form the major contribution to Saturn's outermost E-ring. Today, Cassinis Cosmic Dust Analyzer, an instrument provided by the Max Planck Institute for Nuclear Physics in Heidelberg, Germany, has analysed the composition of this ring with another major finding.
We found very high amounts of salts in the icy grains, and this was a big surprise. In contrast to the pure ice grains, such a high amount of salt is unusual and has some very strong implications for the overall mission and for the science around the moon Enceladus.
The results of these studies are published in a paper in the latest issue of Nature, with Ralf Srama's younger researcher colleague Frank Postberg as the lead author. The implication of this discovery is that extensive amounts of water, oceans or lakes, must be present in the interior of Enceladus or below its ice crust.
We think about more like an ocean, so there must be plenty of liquid water which is in contact with the hot rocky core of Enceladus, and the minerals of the core dissolve in the liquid, and then the liquid forms very tiny droplets which are then jettisoned by the geysers of Enceladus and replenishing the faint dusty ring around Saturn.
After obtaining at a distance composition and density measurements of the water plumes ejected from Enceladus as it passed in front of a star, confirming theoretical predictions that there would be no danger, the Cassini spacecraft has flown past Enceladus 7 times to date. Last October, the 6th flyby was only 25 kilometers from its surface. The Cosmic Dust Analyzer and other instruments scooped up samples of the plumes, and Cassini's cameras and other remote sensing instruments sent back some of the most vivid high-resolution views of this cold, icy world. Multiple fractures slash across the moon's south polar region, and there are fine-scale structures near the geysers. Numerous smooth plains and the relative absence of large craters indicate that these regions are relatively young, hence that Enceladus must have recently been active with some kind of water volcanism or tectonic activity which has renewed its surface.
In order to form a liquid, you need high temperatures. We also found organic compounds and carbonates in the dust grains. And if you put everything together, you can, of course, formate the precursors of life under the surface of Enceladus. And that's something which is also very exciting.
As the Cassini spacecraft pursues its mission around Saturn, these latest suppositions about prebiotic conditions on Enceladus refuel interest about the icy moon. And the European instrument, the CDA, aboard the orbiter, is providing a startling example of remote analysis. There's no need to drill into the subsurface of a moon. The dust particles alone, collected many millions of kilometers away, can help reveal its innermost secrets.